Hello, my name is Joe Evans and I'm a Senior Design Engineer at Dyson working on new products. Today we're here to talk about the Dyson V12 Detect Slim Animal. Over the years, Dyson engineers have continually innovated our designs, and it first started back in 1993 with the DC-01. When James Dyson was developing the DC-01, it took him 5,127 prototypes to eventually end up with the finished product. This was the first ever bagless vacuum cleaner and used our cyclone technology to separate dust from air. Since then, Dyson engineers have really wanted to remove the cord from our products. And to do that, we had to develop special Dyson digital motors. This enabled us to make a cord-free product that was easier to use and you didn't have to plug into the wall. A cordless vacuum is a machine that, like the name suggests, has no cord. It uses battery to provide the power, and this is charged up separately so you can use it any time and any place. This is the battery that provides all the power to the machine, and it's really important that it's replaceable. If the battery on the machine was to break, you could replace each one separately, which is good for the customer and the environment. On the front of the battery, you'll notice there's a red catch, and this moves a small lever on the top of the battery. This then engages on the main body and means that it can attach and won't fall off. In the centre here, you can see there's some holes. Those are the connections to the rest of the system. There's a positive and negative where the main power terminals connect. The actual terminals themselves, which are on the other part of the machine, are gold plated. It means they don't corrode and they can transmit the electricity more effectively. The other holes are for wires for communication, and when this battery is connected into the machine, it communicates with the LCD screen, lets the user select the mode, tells them how much runtime they have remaining, and also information about the type of dust that's gone into the machine. Also, on the top of the battery, there's some small connection features that mean the actual battery is easy to connect and aligns perfectly every time. Another important part of our machine is the filter. It's made up of two parts, the first being the pre-filter, this is this section here, and the post-filter at the back. On this part you'll notice there are 4 seals. The first 2 seals make sure that the air goes through the pre-filter. This is the first stage of filtration and captures the large particles before they enter our motor. On the back of the filter there is 2 more seals, and this makes sure that the air goes through our post-filter and then out through these slots here. We call these exhaust slots. On the front of the filter, you'll notice there are 2 bumps. These actually contain a magnet, so the main body of the machine can detect if the filter is there. When there's no filter, the machine won't work. The filter attaches to the main body with a mechanism called a quarter turn. This means that the filter goes on and rotates to lock it into place. This makes sure that the filter is secured in the machine and all the seals are working properly. The machine can detect the magnets, and now the machine should operate as normal. So let's talk about the rest of the machine. As engineers, we call this the main body, and this holds our cyclone system, separation and motor. As air and dust enters the machine through this hole at the front, the first thing it touches is our sensitive surface. If you were to look down the front of the machine, you'll see some small black lines at the bottom. Those are actually rubber strips around the sensitive area, which behaves a little bit like a trampoline. Once the particles hit that, a little bit like a microphone, we listen to the sound that they make, using a new technology called piezo technology, not pizza. With this information, the machine then knows the amount and type of dust and can react accordingly. I can show you just how this works now. As you can see, the machine ramped up in power when there was lots of dust and debris, and then went down again once the surface was clean. This is really important because it saves energy and increases your runtime. This machine has 12 cyclones, and once the air exits the cyclones, it's directed by the flow fingers. So these bumps move the air from the cyclone and into the filter effectively. On the front of the product here, this is something called our primary separator, or the bin. This captures the largest particles as they go into the machine. Once you've opened the bin, you may notice there's a small black seal at the front. This does something called flowering. This is when the seal moves into a petal shape like a flower, and you can demonstrate this by opening up the bin and seeing its shape. This happens because of some small ribs and notches which are put onto the part to make sure it folds evenly and all the dust can exit the machine. For the bin to open every time, the cam has to be actuated by a small peg on the bin runner. This means that as you slide over the peg, it actuates the cam, which pushes the push rod, which opens the catch, and then the bin is open. As engineers, it's really important that we help the end user of our product to understand how to use it. On Dyson products, we do this by colouring certain components red. The red parts are things that you touch, move, pull and push. These are all the human interactions of our machine. You may also notice this special red strip here. This is made of a special material which is ESD, or electrostatic discharge. This means that when you're using the machine, any static electricity which may be built up, just like rubbing a balloon on your hair, doesn't shock the user. These red strips are connected to the negative side of the battery and mean that electricity is then taken away safely. So let's talk about some of the engineering on this powered tool, the motorhead. Underneath the articulation joint we have two wheels, and we've designed these to be domed in shape. And this is important because it reduces the friction as it moves over the surface of the floor, and it also contacts no matter which direction the articulation head is pointing. On the inside of the machine we have the brush bar. This is powered by a motor and gearbox assembly in the centre. Inside the housing we have a drive system. This has a motor, gearbox and drive dog. The motor drives the gearbox and the drive dog connects to the brush bar to make sure the whole system rotates. As with any of our powered tools, the motor creates some heat, and we have some small fins on the drive housing to disperse that heat. On the brush bar we have a selection of materials to make it more effective. The red material is a nylon bristle, and this agitates the floor surface and lifts any dust and debris up into the air where the vacuum will take it away. The black bristles are made from carbon fibre, and these are softer and swept backwards, and this means they capture all the fine dust and get that into the air to be taken away by the vacuum. Also on the clean head we have this rubber strip at the back. This is important that it's soft and flexible and it conforms to any shape on the floor surface for a good seal. On the front and the sides you'll notice there's some felt material. This is to not damage any skirting boards or other furniture that the cleaner head may get pushed up against.